Okay, so this is the Phet simulation that I've sent you for you to have a little look at. All right, so what I've got here is a container. I can change how big the container is by moving this, and I can heat it up and cool it down by moving this, and I can put gas particles in here. Okay, and I'm going to see the temperature here, and the important one that we want to look at, that you need to keep an eye on here, is the pressure. All right, so you can see at the moment the pressure is 0 because there's no particles in the container. So there's no particles hitting the walls, so the pressure is 0. Now, put a couple of pumps of particles in there. You can see the pressure is increasing. All right, see that pressure going up? So the more particles there are, the higher the pressure. And the reason is because the more particles there are, the more particles are colliding with the walls of the container. All right, so let's now make the container bigger. Now, if I make the container bigger, then the particles are going to have to travel further before they collide with the wall. So they're going to be less, there'll be fewer collisions with the wall of the container, which means the pressure should decrease. So the pressure at the moment is 54.4. If I let go, it drops down to 36.3 because there are fewer collisions with the wall of the container. Now, if I make the container really, really small, we should see the pressure go right up. Okay, now that's because now there's loads and loads of collisions with the wall of the container. You can see the pressure's gone right up to 108 atmospheres. So I'm going to put it back to where it was before. And now what I'm going to do is I'm going to heat up the particles. So if I heat them up, you can see at the top the temperature is increasing. Now, as the particles get hotter, they move faster. And because they move faster, they collide with the wall more often. So you can see the pressure in the top right-hand corner is also increasing as they collide more often. All right, and then you see we get too hot, pressure too high, the lid flew off. All right, and now the pressure is going down because all the particles are escaping. So I put the lid back on. Pressure is now 49.2. All right, now if I cool it down, then the particles are going to travel slower, and they're therefore going to collide less frequently with the walls. That you can see them now getting slower. They're colliding less frequently with the walls, and the pressure is dropping. So you see that pressure dropping? Okay, so what I want you to do is you can come on here, have a little play with it, and you see how changing the temperature, changing the container size, and changing the number of particles changes the pressure. All right?